Hi there, this is just to illustrate the construction of a stack using Java. So I've got an implementation of a class called stack, and I've got a constructor here which is initializing a stack to a particular size of an array of integers. I'm defining a couple of methods within the class. So this is push an element onto the stack, and I'm testing for whether or not the stack is full. If it is, then I'm actually reporting the fact that the stack is full, and in the case that it's not full, I'm just actually assigning to array with element index that element and then incrementing index by 1. On the other hand, the convert operation is to perform a pop operation, check to see whether the stack is empty. If it is, report the fact, and otherwise return the array with index minus 1. So I'm going to decrement the value of index, which is fine, and then got a test for the stack being empty, a test for being the stack being full. Have a look at the logic of these two methods, and so I've got a main method here, and I'm creating a new stack S of size 100. And first of all, I'm going to push 99 onto the stack, push 98 onto the stack, push 97 onto the stack. Then finally, I print out the result of popping an element from S. And if I do that, this is what I get. So I'm going to run the program, and I'm just simply getting the last element that I actually pushed onto the stack. This is the third element I pushed onto the stack, which is entirely right. So I'm sure you could refine this very, very basic program. And the other thing that I'd like you to look at is, I could have used my own system-defined, use the system-defined empty stack exception, but I'm not going to do that, so I'm going to delete that. Don't need it because I've actually replaced the standard words of throws a particular exception simply by reporting the fact that the stack is full and that the stack is empty. But I could have used the system defined exception to deal with the fact that the stack might be full or might be empty when I need them to be the opposite to perform the operations specified. So what I'd like you to do is to think about perhaps implementing a stack by means of a linked list, and I'm illustrating the use of a linked list when I come to talk about a queue. I'm designing a queue to hold the particular jobs required by two or more lifts, and the controller is going to maintain a queue of jobs resulting from people pressing buttons. So anyway, thanks very much for listening once again, and I'll put this